In this video, we're going to go over the 8.1 practice. All right, to convert from degrees to radians, we multiply the degree by pi over 180. But since your answers are in terms of pi, we have to just take the degree itself and divide by 180. And we write the pi next to it. Now what we'll do is we'll reduce this number. So let's do that. He says 1.75, so click that fraction bar, and you say 7/4. So that's going to be 7/4 pi. The way we typically write that is we write 7 pi over 4. That's the same thing. So that is your degree, that is your radian in terms of pi. Number 2. What is 235 degrees expressed in, or number 3, what is 235 degrees expressed in radian measure round to the nearest tenth? Well, this one's kind of similar. We want to take that 235 degrees and we want to multiply it by pi over 180. In this case, since we have it as a decimal form, we're going to put all in the calculator. And this time we want to actually write the whole decimal, so 4.1 to the nearest tenth. So 4.1 would be your answer. Question 4. This one's more like question 2. It says in terms of pi, so 160 degrees times pi over 180. And we just do 160 over 180 pi. Reduce that. And so that's going to be, well, I can do that on my head. That's going to be 16 over 18, which each of those could be cut in half. So it's going to be 8 over 9 pi. 8 pi over 9. You can double check that in your calculator, but that should be 8 pi over 9. All right, number 5. Decimal again, 130 times pi over 180. Put that all in the calculator. .268. So 2 decimal places would be 2.27. All right, question 6. Approximately how many degrees is 4 radians? All right, so now we're going to go the other way. So when we want to know the degree measure, when we're given the radians, we take the radians. We got 4 radians, and we're going to multiply that by 180 degrees over pi radians. So in the previous problem, we had pi over 180. This time we do 180 over pi. So we want to know the degrees. We're going to multiply 4 times 180 over pi into the calculator. And that's going to be about 229.18. And it says round to the nearest tenth of a degree. So if we're doing 1/8, we're going to bump that up to 2. 229.2 degrees. All right, another one here, number 7. We want to get it into degrees again, so we're going to do 8 pi over 3 times 180 over pi. When you have the pi in the top, that one's easy because you can just say, all right, I'm going to put pi in the bottom so they cancel out. Clear all these out here. So 8 pi over 3 times 180 over pi. That is exactly 480 degrees. All right, question 8. That was 7. All right, 0.4. Now there is no pi, but it's still a radian, so 0.4 radian times 180 degrees over pi. So 0.4 times 180 over pi. And that's 22.9. That's 918, so we're going to just keep that at 22.9 degrees. And that would round to 23. Nearest degree would be 23 degrees. All right, number 9. Express in degree an angle of 2 pi over 15. So 2 pi over 15 times 180 over pi. That's 24 degrees. Number 10. For 5.1 radians, here I'll do number 10 right here. 5.1 radians, 2 degrees, so times 180 over pi. And that'd be about 292.2 degrees. Round to the nearest 1 decimal place, so 292.2. And number 11. Heck, we could probably squeeze number 11 in here. 2 pi over 9 times 180 over pi. Pretty repetitive stuff. And that's 40 degrees. All right, number 12 is the last skill on here. So let's write this here, number 12. We want to know the circle has a radius of 7 centimeters. What's the length of an arc subtended by a central angle of 3 pi over 5? And this is your formula. S equals r theta, r times theta. So S is your length, r is your radius, and theta is radian. So S is going to be what we're trying to find. Your radius is 7. And your theta, arc in the central angle of 3 pi over 5, that's your radian. So I'll plug that in there, and then we're going to multiply all that together. And that's going to be about 13.19. So it's going to be 13.19 And then whatever the unit is, since we're talking about centimeters. Length is in centimeters. All right, number 13, same formula. Arc of length 80 inches, so S equals R theta. The length 80 inches. Now this one here, we got the length. So that is your length. That's your S. Angle of 3.2 radians, that's your theta. And we want to know what is the diameter. Well, that's twice the radius, right? Diameter equals 2 times the radius. So we're going to get the radius first. So first we have our S, that's going to be 80. We don't know R, but we do know that the theta is 3.2. So let's first divide by 3.2. And your radius is going to be whatever 80 divided by 3.2 is. All right, 80 divided by 3.2. That's 25 even. Cool. So we have our radius now. We get all that. So remember, your diameter is 2 times the radius. So 2 times 25. That's going to be 50. That's going to be 50 inches. All right, 14. A circle has a diameter of 50 inches. So diameter is, excuse me, circle has a diameter of 10 meters. 10 meters. What is the length of an arc subtended by a central angle of 4 radians? So the central angle is 4 radians. We want to know what is the length of an arc. What is that S? Well, first, a diameter of 10 meters equals a radius of 5 meters, because remember, radius is half of a diameter. So S equals R theta. S equals 5 times 4. And that's going to be 20 meters. All right, question 15. The circle has a diameter of 32. By this time, if you see a diameter, know that the radius is going to be half. So the radius would be 32 divided by 2, which is 16. Oops. 32 divided by 2 is 16 inches. So your radius is 16. Central angle that intercepts an arc with length 80 inches. So your length is 80 inches. Radius is 16 inches. What is the measure of the arc in radians? So radians is what we're trying to find. S equals R times theta. 80 equals 16 times theta. Let's divide. 80 divided by 16 is whatever your answer is going to be. That's going to be 5. So your radian measure is going to be 5 radians. And that's it. Oops, which one did I miss? see. It says it's wrong, but it's right. So we'll fix that on my end.